Hey, welcome back. Good to see you. We're talking about reflections of functions over the x and y axes. Now, there's some common ones like this one and some others. And then there's some uncommon ones that we'll look at. Let's get going. All right, those are the 5 common functions that we're studying. So let's look at y equal x squared. Now, if we were to reflect y equal x squared over the y-axis like that, you can see that it's the same function. Okay, that is a property of an even function. We're not really going to study that and say that too many times, but it is an even function. I may ask you on the little quiz. Now, if we reflect it over the x-axis, then yeah, you get a different function. Let's keep going. All right, y equal x to the third. We start with the parent function. If I were to reflect this one over the y-axis and then this one over the x-axis, they look the same. When you reflect over the y and over the x and get the same function, that's a property of an odd function. And again, not anything in particular that we're going to necessarily worry about, but it's fun. All right, so the square root function. Now, this is an outstanding function because if you reflect it over the y-axis and reflect it over the x-axis, you get 2 different pictures. And then what if we reflect it over both axes at the same time? Boy, that would be a mind blower. Let's keep going. E to the x is kind of like the square root function. If you reflect it over the y-axis like that and over the x-axis like that, you get 2 different functions. All right, the absolute value function. You should kind of predict that if we reflect it that way, then we get the same thing. And so this is an even function. And if we reflect it that way, then we would get that. So the question is, well, which way do you flip it? Or do you flip it both ways? And that's what we're looking at. All right, we're looking at these functions and some functional notation like that maybe. And all right, so it's all about reverting back to the parent function. Well, let's look at replacement here. You may want to pause the video and guess that. If x is replaced with negative x, where does this point map to? It will map from here to there because the coordinates of A are negative 3, 1. And if we replace that with negative x, it'd technically be negative 3, 1. Well, negative 3 is positive 3, so it's there. You might want to pause the video and read that if you want to. That's what I just said. All right, and then so that would clearly be D. Keep in mind at Socrative, if I refer to problem number 2 or problem number 1 that we just did, that's what I mean. I'm talking about that. All right, so if we replace y with negative y, so this would be, again, negative 3, 1, and we replace that with negative 1, then we would map to D. You may want to pause the video and read that. Okay, so we got to decide when we have a function or a negative in a function, well, what do I revert or what do I replace to revert it back to the parent function? That's all that means right there. All right, so let's play this game a little bit. Clearly, you're going to say that's with x, okay, number 3. Number 4, you're going to say that this negative is not with x. If it was with x, it'd be right there. So that's with y. And that's just all you're saying is, well, we have a negative. Is it with x or with y? And clearly that's with x. Okay. I don't know why I'll keep jumping. Let's do all the problems that we have. That's clearly with x again. All right, and so it's a pretty easy decision. So then it would be like, okay, well, I need to replace x with something to revert that back to the parent function. And so it would be this. I mean, that we're replacing that x with negative x. And then that right there is what we read. Now, when there's just reflections, I don't guess that's going to work. Darn it. Try again. Yeah, there it goes. When it's just reflections, we probably really don't need to do that. But to get it going towards the translations and the stretches and shrinks, let's say it anyway. All right, so we're replacing x. And then it would, the 2 negatives cancel right there. And then you get it back to the parent function. So if you replace x with negative x, you were flipping over the y-axis. That's what we did right here. When we replaced x with negative x, we flipped over the y-axis. Let's see if I can get back to where we were. All right, there. All right, and so let's look at that with some functions. We just said all of that. You can read it. If we have a negative with x, I don't guess this thing's going to work the way I want it to. Try it one more time. Oh, well. If we have a negative with x, then it reflects over the y-axis. So this is the parent function, and it reflects over the y-axis. And it doesn't matter what function it is. If you have a negative with x, then it reflects it. Again, this is the parent function, and it reflects it over the y-axis. And it doesn't matter what function you have. Keep in mind, for this function, it has been reflected. Okay, I had to draw it on two different systems so that you could see it. But it's been reflected, but it's the same thing. It's because of where the negative is. Even function. All right, and then for that function, it reflected. The blue is the parent. The red is the parent reflection. All right, again, so that's an even function as well, because when you put a negative with x, you get the same function. It does reflect. All right, now this hadn't been reflected yet, so even in a non-common function, so it hadn't been reflected yet, if there's a negative right here, that means I'm reflecting it over the y-axis, and so it would look like that. Now it's reflected. Let's keep going. We got a lot to do. All right, so this is a negative with y, so clearly that negative is here, so you would make this y negative y to get that back to f of x, to y equal f of x, and then I'm just going to scroll through the next couple of slides so you can pause them and read them. That's what it says, what I just did. All right, and so we did that, and we get it back to the parent function, and it doesn't matter which one, parent function. If you have a negative not with x, then it flips over the x-axis or vertically. And to flip vertically, and there's the e to the x function. There's x squared. So this time, when the negative is here or not with x, then it does change and it reflects over the x-axis. X cubed, absolute value. And then this function hadn't been reflected yet. So if we put a negative right here, then that reflects over the x-axis or vertically. Again, to reflect vertically, you have to have something horizontal that's stationary to reflect over it. All right, so let's play a couple of these games. And so I want to pause the video, so I'm going to scroll through them. That one is B. This one is A. Whoops, A. All right, I want to pause the video and see this one. The negatives here, that makes it a vertical. This is the parent function, and it would reflect down to here, which would make D the answer. All right, negatives with x. This is the parent function. We're going to reflect that over the y-axis because the negatives was reflecting horizontally, so it should be D again. That's not the answer. D. All right, and then got a few more. If you put the negative there, you replace y with negative y. So if you took this point 1, 1 and replaced y with negative y, I'd map to 1, negative 1, which is C. All right, same thing. You take that point, you replace the y coordinate with its negative value, so it'd be 0, negative 1, which is A. 13, now we're replacing x with negative x, so technically it's negative, negative 2, negative 8, that you're replacing negative 2 with negative, negative 2, but that simplifies to positive 2, so that should be E. It's getting long, but let's finish up. I think we're pretty close. All right, and so we want to reflect this thing. We really just did this one a while ago, that we reflect that thing vertically because the negatives with y, and y is the vertical variable, but to reflect vertically, you have to reflect over the x-axis. So, see if I can get this right. Looks like the answer is A. Okay. We do have a cameo appearance. Let's see if we can get this going. I'll give you a hint. I think there's one thing that we can all agree on. I think we've done this one before, but we can all agree that we miss Tom Petty. All right, guys, I'll see y'all later.